Good evening, class. Tonight we're going to be talking about uh, page number 13 on a question sheet that was assigned the other night. We're going to be wrapping that up and moving on to roof drains. Okay, do a little more on roof drains. So what I'd like to do is, let's get this set up, is start with number 111. So get that sheet ready to go. Okay, let's see what we got. All right, this is going to be on page, you got your book there, code book, and you want to follow along. It's going to be in the 175 to 178 range. Okay, the first question is, what is the maximum distance from a trap to a vent on 4-inch pipe? Now, if I remember right, last week or the other night, we did page 12, and I think it got up to, like, say, 3-inch pipe. So this is still table 1 on page 178. Okay, so they used, there's 4 questions off that little table that they have there of all of the charts and information in this book. This is one of the most important, not so much for the 3 and 4 because we don't do them very often, but on the 1.5 inch and 2-inch pipe. Okay, remember, you can go from the stack or wherever it's vented, the vent, back to the weir of the trap. That's your 5 feet or 6 feet if it's 2-inch. Okay, so that was page 178. Okay, number 112. How many fixtures can you put on a battery, either a loop or circuit vent? And the answer is 8. Okay, that would be on page 177. So it just happens to be on a page just before this page we're on. So let's turn back one page. Now, if I remember right, when I was trying to balance one class and the other, with I guess some success, although it really it got confusing. I don't think I covered battery vents with tier 1. I'm pretty sure I did not. It's a little bit advanced for tier 1, but to cover this, I'm going to have to go over it. So you guys, tier 2, bear with me. It'll be a review for you. Tier 1, this is called a battery vent. A battery vent is 2 or more floor-mounted fixtures. Okay, like side by side, not so much residential, but commercial. All right, so if you got a row of floor, now the key is they got to be floor mounted, not wall mounted. They got to be floor mounted, right? They can't flush back into the wall. That's not a battery. So they can be like floor drains. What else? I guess some urinals can floor. Well, they have to be floor mounted. Let's see what they got here. They do mention urinals, but anyway, normally they're water closets. So let's leave that one alone. Okay, we're only going to be dealing with water closets, but remember what a battery is: 2 or more floor-mounted fixtures. The vent is between the last 2 fixtures. All right. So the question was, how many fixtures can you put on a battery, either loop or circuit vented? Now, that question could be worded a little better. With a single vent is the way I would have worded it, because you can put more than 8 on a battery, but you would have to have more than one vent. So let's see what that means. So you guys, tier 2, I think you know what I'm talking about. Tier 1, maybe not. So let's see. Let's say we have battery vent. Here's our stack. And we'll put this like a clean out at the end. This will be 4-inch, and this is going to be 4-inch, because we're going to have more than 2 toilets on one level. Okay, as soon as you got more than 2 water closets, you got to jump it up to 4-inch. What I'm doing is I'm adding us 2 floors, because I'm going to need this one a little bit later on. So let's do this. This will be identical, almost identical. Okay, these are the symbols for water closet on like on a battery. They're kind of like sort of like three-dimensional. Okay, so you get 5 toilets lined up. Let's not talk about this one yet. Let's just do the top floor. Okay, this is going to be a circuit vent. Okay, the vent stack is over here. It'll be 2-inch. Now, the vent stacks that we work with will never go bigger than 2-inch. The book does go up to 2.5-inch, I believe. There is one sketch where if you got enough toilets on it, but we're not going to really, there's no need to get that big. We'll just go with the 2-inch. This main stack is, like I said, 4-inch. And that's right here. Okay? So, where does the vent go? Between the last two. Okay? So I think you'll all agree that this is a very economical way to vent water closets, because otherwise you're going to be venting every fixture. This one here reminds me a little bit of a wet vent. You got more than one fixture on a vent. Okay? But it's called a battery vent. A battery means a group of fixtures like this. All right? So circuit vent. Now here's the way to remember it. The circuit vent is one and the loop vent is the other. Okay? Make this one a loop. I know I put circuit. This is going to be a loop vent. Now, if you want to see the book version of this, it's on page 204. It's where they have the sketch. I'm going to take a quick peek at it. I wrote down the page number a while ago. Let's see what they got. There it is. Page 204, 205. 204 has a circuit vent. Top of the page, you'll see circuit. Highlight it, underline it. Okay. And it's going to be a little fancier version of what I'm showing you right here. Okay. And unfortunately, what they have here is a very long battery vent with a couple of vents coming off it. I'm going to keep mine a little cleaner than theirs. Clean meaning I'm not going to add sinks and floor drains to it, at least not yet. All right, so here it is. The vent goes between the last two. The size of the vent is 2-inch. Okay, now, how can you tell a circuit vent from a loop vent? Now, this, by the way, don't worry about this for the trade, because this would be a big commercial job with an airtight set of blueprints, I'm sure, that your boss would have to figure out. Don't worry about it. The residential level, that's different. Then you make up everything. It's all on you. But commercial, no. But you need this. You need to know this for your license, all right? Comes up all the time on tests. Here's where the vent goes. Remember, the general rule for a vent is half the size of the drain, but not less than 1 1/4. Okay. Since this is 4-inch, right here, this is 2-inch. And it loops back to the stack or the vent stack. So that's how I always remembered it. What's the difference between a loop and a circuit? Well, let's see. The loop loops back. Just remember that, and the other one falls into place. Okay, so this is a loop vent. Okay, so keep that in mind. One vent now, straight up. And remember, it's got to be 6 inches higher than the highest fixture in that room. Sink is, we'll say, 36 inches. If it was any kind of countertop sink or whatever. Laundry sink. Kitchen sink. So what I would suggest is whenever you run horizontal pipe like this, always run it at 42 inches. I think a lot of you already do. You guys have been running vents. I'm sure that's probably the standard number you work with. Is that always puts you 6 inches higher than anything else in the room. Okay, so that's how high this is. I'm jumping the stack and tying into the vent stack. Could I have tied into the main stack at this height? Yeah, could have. But if we got a vent stack, that's probably where we're going. Okay, that was question number 112. It's how many fixtures can you put on a battery, either loop or circuit vented? The answer is 8 on one battery vent. Okay, so I could have added 3 more toilets and put this vent between the last two, which would be over here somewhere. If I went over 8, I would have to add I would have to like start from 1 again, and maybe after the 9th toilet, I'd have to put a vent. After between the 7th and 8th, they automatically have one, and then just start like over again. So if they went out maybe 10, 12 water closets, there'd be one between 7 and 8, and one between say 11 and 12 on the same line. Okay, never seen that in the, well, actually there is a sketch in the book like that, but in real life it doesn't happen very often. Okay, that was on page 177, 11, paragraph 11A1B. Okay, that was paragraph 11A1B on page 178. I'm sorry, 11A1B on 177. Yep, right in the middle of the page, right across from the center ring. You'll see 8 floor outlet toilets. 2 to 8. Okay, next question, number 113. How far from an opening door or window does a vent stack have to be? Okay, so we're leaving the battery. All right, we don't stay there for long. And now we're going to, how far from a door does that have to be? You know, and I don't have the answer for that. How far from an opening door or window does a vent stack have to be? This was one page where I didn't have an answer sheet, and I missed that one. Okay, I can tell you the answer. The answer is 10 feet. And let's see, question 112. If I can find it real quick here, because I did number them. Oh, 113. I'm sorry. Damn, I don't have it here. Okay, but the distance is 10 feet. How far from an opening door or window does the vent stack have to be? Okay, so let's see what that would look like. Okay, yes, I did find it. Okay, this answer is, I'm going to write it down myself. It's 10 feet, like I said. It's on page 175. And it is 10 feet horizontally or 2 feet above. And that's paragraph 6A1B. 6A1B. A1B. Okay, pain in the neck, I know, but get used to working to find these answers, because it's nice to know the answer, but sometimes you have to back it up, especially if you got a tough inspector who thinks he knows the answer. And you never rub it in his face, of course. You just politely show him the error of his ways, right? Okay, so how does that work? Okay, just leave this here. Keep this in mind. And let's go to a roof of a house. Okay, here's a house, and they have an addition on the house that they put on. It comes out like this and down. Little family room over here. And they want to put a bathroom in. And the vent is going to be, let's lift this up. And we got a window right here looking out. Okay, you want to run a vent out here, right? And down to a bathroom down below. You have to be 10 feet from here to the window. Okay, this is an important one. This does pop up for real out in the trade. I've seen this a handful of times. Okay? So if I saw it a handful of times, you're certainly going to see it also. So be careful about this one. And this is typically where it happens. You got a vent coming out a lower roof window, which would be like an add-on addition like this. If they got the bathroom close to the main house and there's windows above, right above or nearby, there's an arc. In other words, if you're standing in the window and you put your tape out, it cannot be closer than 10 feet, like an arc, almost like a circle, like an arc of like a compass. So if it falls within a 10-foot swing of your tape, you got a problem. And it's not something the inspectors miss, right? If you're close, I imagine most inspectors would let it go. But if you're tight, you're in like 4 or 5 feet, forget it. And the idea is that the wind, especially like a prevailing wind in the summertime where you have this window open and the sewer gas, it would come in the house. Okay, so it's pretty obvious the problem there. All right, so it's 10 feet. Now the other one also pops up quite often. This has also happened to me a number of times. So that's half of the answer. The other half is you got a skylight. So we're looking down on a roof, right? Just imagine this being a roof. We're looking down on it. We'll say it's kind of like, not too good at this 3D stuff. But let's say it's something like this. And we got a roof. All right. And yeah, I guess that's right. Something like that. Over here, we have a skylight. Once in a while, you catch a kitchen in the front of the house or a living room. And we got a skylight, an opening skylight, not a fixed skylight. There doesn't seem to be too many fixed ones these days. I know my daughter has one of these that's opening, but she doesn't have a vent around it, so it doesn't matter. But if this is an opening skylight, I would have to have a vent 2 feet higher, like this, than the window. Okay? So if I want to put a vent very close to here, I could, but it would have to be, the opening to the vent would have to be 2 feet above the highest part of the skylight. So those skylights, they open with like a crank, or some of them electric. You'd measure from right there, from the top of it to the top of your vent. So as long as you're aware of it, it's not a problem. But if you go lower than 2 feet, what happens? That is a problem. Now you have to go 10 feet, right? So you'd have to go 10 feet from either corner. I'll just go from the middle to make it easier. So it'd be an arc of like 10 feet like that. Right? 10 feet all the way around. If you were not higher, not above so much. Above, obviously, once you get above 2 feet, the 10-foot rule is off. But if you're lower than 2 feet, in other words, up to like right about here, like that, you got to go 10 feet. Okay? So if you're not 2 feet above, you got to go 10 feet to the side. Again, for sewer gas. Okay? Doesn't pop up all the time, but once in a while. It pops up a lot for your license questions. On your license questions. Okay, so that was number 113, page 175. Okay, let's see. We got question number 114. If a vent goes through a roof with a garden on it, how high must the vent stack be above? I've never worked on one of these. To me, this is like, I won't say like New York necessarily, but maybe more like Providence or Boston probably, where you have an area where people can walk around, not a roof that you're not really supposed to be on, but a roof, that has a door to go onto it, like you see in movies, the chase scenes a lot. They'll have like a door going onto the roof. I suspect that it might be against zoning if it doesn't have like a wall all the way around a certain height. We don't have that around this area here. But I believe that's what they're talking about. If you have like a garden up there or a place that people can walk around and so on, if there's a vent coming through that roof, okay, how high does it have to be above the roof? And they mentioned a roof with a garden on it. Okay, the answer is on page 175. And the answer is 8 feet. Okay, and I think I mentioned this to you. Here it is, 8 feet. Yeah. Okay, now, I always remember this question because when I took my license exam, we used to take the written first. And then in those days, you'd have to wait for them to correct it. So you might get your results weeks later, a month, or maybe a month later. And then you took the practical part of the exam where you went and you saw some like shop projects at a high school. And you had to bring a fitting with you. I think it was 1.25 inches or 1.5 inches piece of pipe, a foot long with a male adapter. And you had to solder it on in a vise. It's to show that you can actually know how to solder. I guess in my father's time, they had to wipe a lead. They used to call it wiping a lead joint. But Lead went out so long ago that when he took the exam around 1948, 1950, the lead was still on the exam that you had to wipe the joint where you like put the lead together using a rag, and they called it wiping. I never saw it done. So he had to learn how to do it, but I don't think he ever did. It was actually the generation before him. But we were still doing the copper like 40, 45 years ago. And you could be asked some questions exactly like what I'm asking you. And I was asked how high does a pipe have to be above a roof with like a garden on it? I honestly didn't know the answer. And I'm bumbling around, and the guy was he was a nice guy. He said, "How tall is a ball player?" Wilt Chamberlain. I think I told you tier 2 guys the story. At the time, I believe Wilt Chamberlain was still a big star in the NBA. This being in the early 70s, mid 70s. And I said, 7 feet, which he was. He said, add one. 8 feet. He says, you got it. So in other words, he gave me the answer. Don't plan anybody giving you the answer. Plus, I don't think there's any more. Everything now is in writing and multiple choice. The other question that goes with that, is if you go through a roof with a garden on it, besides going, and here it is here, if you read to the next question, they gave you the answer. It's 8 feet. What else do you have to do? And then the answer they're looking for is part of that same sentence where it says 8 feet. It says that you have to increase to 1 pipe diameter. All right, so it's part of the same sentence. So it's the same paragraph, same page. Okay, so if you're coming up through the roof with 3-inch, for example, you got to bump it up to 4. If it's 4, you'd have to kick it up to 5. All right, something at this level here would probably be commercial, and you wouldn't have to come up with anything because it'd already be on the print. Okay, now I saw this as an inspector, and I think I've mentioned this to you, but in case I haven't, when you're working off a blueprint, especially like a commercial building where you got a clerk of the works and a big job, or whoever is designated to keep an eye on the job, could be an architect, engineer, but usually clerk of the works if it's big enough. So he's there full time. You can meet code, but not meet the terms of the specs, right? The specs would be in a spec book. It would list Joe Sam floor drains or whatever it is, Kohler fixtures. Excuse me. You can substitute something less expensive for you as the installer or the plumbing contractor, and it would be okay with me as the inspector. I don't care. You meet code. That's main difference to me. The problem is the person that you're working for. You're not meeting the contract. You're violating the contract, and the problem is you probably won't get paid, or there'll be a deduction for the substitution that you made. Okay, so the book says you got to kick it up 1 pipe size and go 8 feet up. Now the other thing is, and they don't mention it here, it's probably going to be cast iron. Now I've never got involved with this 8-foot deal, but just think about it. Even cast iron, 8 feet straight up, you're going to have something supporting it. Usually there's like some kind of guide wires. They put like a collar around the pipe, and you'll see wires going down, almost like a radio tower. Again, not my thing, and it's not a question here. But I imagine that somebody's going to have to make sure that that pipe is properly supported. Okay, that was number 114. 115. I'm sorry, 116. What's the minimum size vent through a roof? Okay, the minimum size vent through the roof is on page 174. And it's 2 inches. Okay, it's about 2/3 of the way down the page. What I did is I circled it, highlighted it, and I actually put the question in here. It must have been last year. Number of the question. Okay, the minimum size vent through the roof is 2 inches. Okay, and that's it. So that would be number 116, chapter 10, section 1016, paragraph 5B2. Get used to these paragraphs, subparagraphs, and subparagraphs, okay, because that's how this book works. It's not like a textbook. Okay, they have all these little paragraphs and then subparagraphs. It goes numbers, letters, then back to numbers, then letters. I've seen them go like double B once in a while, or double I, or something like that. So get used to it, because that's how they do it in this book. Now they go back to battery venting. I shouldn't be complaining. I mean, the questions are good. It's just that they're kind of all over the place. Okay, what are the two kinds of battery vents? Okay, I put them up here. There was loop and circuit. Okay, now this is the loop. All of this stuff loops back to the stack. All right, and the answer is on page 177, 11A1. So let's flip the page over, 177, 11A1. It's actually they're all these questions are together. 117, 18, 19. 17, 18, and 19 are all together right under where it says circuit and loop venting. Okay? All right, let's do the answers, then I'll come back and do to the sketch over here. All right, so that's circuit and loop. Explain the battery loop vent. Okay, I can explain it all day long, but I suspect the sketch is so much better than trying to just explain it. It's a vent located downstream of the last fixture. Okay, that sounds a little confusing. All right, downstream on this sketch is going this way. All right, and I believe they say it's between them. Okay, so it's downstream of the last fixture connection of the battery. All right, the last fixture connection would be this one, right? So downstream would be right there. Okay, now, if you want to add a little bit to this, you guys, tier 1, don't worry, because you got to do tier 2. And if I'm still doing this and whatever, or some other instructor, I'm sure we'll go over this again, so don't worry too much about it. But if you want to add to this, sometimes what you can do is this. You can slide in a floor drain. We'll say a 3-inch FD. Now, this would be part of the 8. So you do 1, 2, 3, 4, 5, 6. So I still put the vent between the last two. Now, if I'll put some labs on this thing, I'm going to put the labs could go in here. They don't affect the battery. I like to put them over like this, side by side. Now, by code, I'd have to probably put more labs in here. Now, remember, this vent, although it doesn't look, it has to be pitching up this way to the stack, right? I know this one here looks like it's sagging a bit, but you get the idea. A couple of, like double TYs, side-by-side labs. You could have one of those. They have it in schools. They have those round labs where you can fit maybe 12 kids in there at one time because it's a circle. But this would just be labs. Okay, they would go like this. The book sometimes puts them in here, which gets a little confusing, but that's how it works. The battery is right in here. Now, the last thing I'm going to mention on this sketch is a relief vent. The book gets into relief vent, and if you get a test on a battery vent, I am sure you're going to see a relief vent. Now, the relief vent, I don't know if you guys can see me in color or not. I don't think so, but if you can, this will help. The relief vent goes between the stack and the first fixture on every floor below the top. And you might think, well, why do you need that one here, but not here? The reason is, remember, up here, look where my finger is here. From here up is all air. So this whole thing here is being vented here and here, right? But down here, it's not, because this is wet. Most of the time, of course, it's not being used, but it really cannot be used as a vent like it is here. It's like a stack vent. Up here, it's just a glorified stack vent. But because you're so far out, you got to help it along. Down here, you don't have that. So what you have to do is put a relief vent we'll put that floor drain back in there too. Okay, so this is 2, this is 2, 2. This, by the way, would be 1.25 because there are sinks, right? So from here back is 1.25. Same thing on this one if I had sinks there. All right, this is called a relief vent. Okay, this here is a relief vent. So if I had another floor, another 20 floors, it doesn't matter. They would all look like this. The only floor that looks like this is the top floor. All right, top floor only. No relief vent. Okay, so right here, there's nothing there. Okay, so if it was a one floor, that's it. That's what it looked like. But as soon as you start putting more floors in, now every floor after this one are identical to this floor. So if there's one, just keep adding floors that all look like this. Okay. Now once you get over, I think it's 10 stories, you got to start putting, you got to start adding, changing your vents a little bit. But for our purposes, this is just fine. Okay. Any questions? No? Okay. All right. Let's take a look at the last of these questions. See how we're doing for time. You're doing good. You got time. Okay, explain a battery loop vent and explain a circuit vent. Okay, the only thing I didn't do was a circuit, which is the last question. So let's see what happens. Now, anybody zoning right now, you got to kind of tune back in because this is a change. I'm going to get rid of this, like this, rid of this. Okay, this all went away. Okay, now on the top floor, everything went from pitching this way to pitching that way. Okay, this is actually pitching down. I can't have that. I'm going to get rid of these sinks because they're in my way. All right, make them disappear. Okay, so what happened? We're going to move the vent stack from here, left side, to here. Now don't worry about where this vent goes down below. I don't have time to deal with it right now, but this would come down here and go out under the floor, whatever. Okay, and at some point this would come across and join the circuit vent, but in this case, it's going to be a the loop vent would be over here, like a regular house vent stack. This one here, we're going to leave the vent there and just leave it alone for now. We'd have a future vent connection down in the basement here somewhere. Okay, so what happens? Up here, we go through the roof. Okay, and over here, we're going to take the vent and go the other way. All right, instead of going left, we went right. And this is the circuit vent. That's the difference. That's it. This doesn't change. It just goes away from the stack. Loop loops back. Circuit goes the other way. Okay, now this side here, same thing. However, my relief vent is a bit longer because it has to travel across to join up with the battery vent, which is here. So the relief vent is actually in two places now, like that. And it's pitching up that way. Okay, now because it's a relief vent for all of these here, it is 2-inch because it's venting the water closets. And this is 2. And this is 2. But remember, at some point, you're going to have to jump this up to 2.5, but we're nowhere near that. Okay? 4-inch handles a ton of water closets. I think it's like 158 fixture units. You're going to be You could easily do 3 floors with all these closets, and you're still going to be using 4-inch. Okay, here's your relief vent, which is only on the floors below the top floor. But the circuit, remember, is over here to the right, away from the stack. Everything pitches uphill. What I would suggest you do is to take a look at what I have here, look at the one in the book, draw your own. Get used to drawing these things, and keep it. Right? As you can see, it's easier to understand if you got a sketch than the way they write it up in the book. The book, especially on page 177 in the middle there, there's got three answers within the one or two sentences. I think this is much clearer than the book, having a sketch. And also write down page 204 and 205, I think it was. Yeah, 204 and 205. Those are the actual book sketches of this circuit and loop vent. Okay, just about on time. Okay, I'm going to shut this off. When I come back, what we'll do is we'll start on the, I was debating whether to continue on with the roof drains, but since I already introduced it, might as well just stay with it, because we got some math. There's a chapter on math that's pretty involved, and I was going to substitute that for a video and an assignment, because it's a long assignment, but we'll do that another time, maybe next week. Okay, so right now what I want to do is to pick up where I left off on roof vents. So what I'm going to do is shut this off, and I will see you in a minute.